Hi, and welcome to the Magic of Mathematics with Mrs. Arnold Harsley. We will be looking at Pythagoras in 2D, finding unknown lengths of right-angled triangles. So today's objectives are to understand Pythagoras' theorem, to find the length of the hypotenuse of a right-angled triangle, and to find the length of the shorter sides of a right-angled triangle. So what is Pythagoras' theorem? When a triangle has a right angle and squares are formed on each of the three sides of that triangle, then the biggest square has the exact same area as the other two squares put together. So I'm just going to grab a pen. You can see that we've got the right angled triangle. I'm just drawing here in black. Right there, it's the white Lego bit. So there is your right angled triangle there. And it says the biggest square, so that's this one here, has the exact same area as the other two squares put together. So that's this square added to this square would have the same area as this square here. Let's just put that to the test. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 for that one. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 for that one. So 9 plus 16 is 25. So it's saying that those two together should have the same area as this red one. So if that's true, there should be 25 on the red one. Let's just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So this is Pythagoras' theorem, and it can be written as a formula. The formula is here. A squared plus b squared equals c squared. So that's a squared plus b squared equals c squared, where this, for example, is side A. So the 9 is a squared. This length is b. So the 16 is b squared, and we've added them together. And that equals the same as c squared, which is this one here, where the hypotenuse, which is the longest length of the triangle, is c. And it tells us that. C is the longest side of the triangle. It's called the hypotenuse. A and B, and I've put A here and B there, but they can be the other way around. It doesn't matter, but I always tend to keep A as the shortest side. But if you wanted to have them the other way around, that's also okay. So A and B are the shorter sides, and they're called legs. So in this first example, we're going to find the length of the hypotenuse. So remember, the hypotenuse is the longest side of a right angled triangle. I've already labelled it C, and the two shorter sides have been labelled A and B, and they're known as the legs. So the formula is a squared plus b squared equals c squared, but I prefer to write it as c squared equals a squared plus b squared. And so what you do now is you substitute the values into the formula. So we have c squared equals, it's telling us a is 5, so it would be 5 squared add, and b is 12, 12 squared. So c squared is 5 to the power of 2, which is 5 times 5. And then you add to that 12 to the power of 2, which is 12 multiplied by 12. So 5 multiplied by 5 is 25, and then you add to that 12 multiplied by 12, which is 144. So c squared is 169. Now that's c squared. So in order to calculate the length of c, we need to find the square root of 169. So c is the square root of 169, which is 13 centimetres. So this side here is 13 centimetres. In this second example, you'll see that A has the length of 7 centimetres, C, the hypotenuse, the longest length, has been given as 25 centimetres, so this time you're being asked to find the length of B, one of the shorter sides or legs. So this is the formula that we use to calculate the hypotenuse. We're just going to swap this formula around so that you can find the length of B. So because we need to find the length of B, we start the formula with B squared equals C squared subtract A squared. So it's always the longest side, the square of, subtract the square of the shortest side. So just like before, we now substitute the values into the formula. So B squared is, so C is 25, so that's 25 squared. Subtract, and A is 7, so that's 7 squared. And now we calculate that. So B squared is, so 25 squared, or to the power of 2, is 25 multiplied by 25. And you're going to subtract from that 7 multiplied by 7. B squared is, 25 multiplied by 25 is 625. And we're going to subtract from that 7 multiplied by 7, which is 49. So B squared is 576. But that's B squared. We want to find the length of B. So you need to find the square root of 576 to find the length of B. So B is the square root of 576. And if you pop that into your calculator, it will tell you that the square root of 576 is 24. So that would be 24 centimetres. So the length of B is 24 centimetres. And in this last example, you'll see that we've been given the length of B, which is 8 centimetres, and we've been given the length of C, the hypotenuse, the longest length, which is 10 centimetres. So you need to find the length of this one, A. So again, this is the formula that you would use if you were trying to find the hypotenuse, and we're going to take that formula and transpose it, rejig it, in order to find the length of A. So because we need to find the length of A, we start the formula this time with A squared equals the longest length squared, which is C squared, subtract, we're subtracting just like we did for leg B, we're not adding, B squared. Now you substitute the values into the formula. A squared equals, C is 10, so that's 10 squared, subtract, and B is 8, so that's 8 squared. A squared is 10 squared, or 10 to the power of 2, is 10 multiplied by 10. And you're going to subtract that from 8 to the power of 2, which is 8 multiplied by 8. So A squared is 100, subtract 64. A squared equals 36. So that's A squared. That would be the square that would attach itself to A, but we want the length of A, so we need to find the square root of 36. So A is the square root of 36. A is 6 centimetres, because 6 multiplied by 6 is 36. So I'll just write that in. A is 6 centimetres. So today we discovered that Pythagoras' theorem means when you add the squares of the two smaller sides of a right-angled triangle, it will equal the square of the longest side, known as the hypotenuse. We also found the length of the hypotenuse using Pythagoras' theorem, and then we also found the lengths of the two shorter sides, known as legs, of a right-angled triangle. Thank you for watching The Magic of Mathematics with Mrs. Arnold Harsley, and until next time, see ya.